What was the big discovery made by BICEP 2 in March 2014? And what is BICEP 2?
BICEP 2 stands for the Background Imaging of Cosmic Extragalactic Polarization. It's a telescope used in an experiment done in the South Pole, where the air is clean and dry, detecting weak microwave radiation from space.
In the beginning of the 20th century, astronomers noticed that galaxies were moving away from each other, and the further apart they were, the faster they moved.
Physicists theorised this meant that the universe was expanding, and that at some point in the past, it must have been very small, dense and hot. They called this idea the Big Bang.
Then in the 1960s, two astronomers discovered something called the Cosmic Microwave Background Radiation, the CMB, a faint glow or temperature that seems to permeate the entire universe.
This further supported the Big Bang because the only way two extremes of the universe could have the same temperature was if they were close enough to each other at some point in the past.
The theory traced the origins of this glow to 380,000 years after the Big Bang, the point where matter started to clump together enough for light to move around freely. But what happened before this, and how did it happen?
Inflation is the best leading theory, or group of leading theories, of how the universe came to be in those early moments of expansion. It's the mechanism, the mathematical details that explain what happens before the 380,000-year horizon of the CMB. It beautifully solved many of the problems with the theory of the Big Bang, but there has only ever been circumstantial evidence for it.
Like any good theory, inflation needed to make a prediction that could be tested directly. In the 1990s, more precise measurements found that the CMB is not perfectly smooth, but has ripples in it.
Inflation theorised that these ripples were the result of quantum fluctuations that were amplified when the universe expanded.
When the universe was that small, the weird world of quantum physics ruled. Energy fluctuated out of nothingness, particles popped in and out of existence, their probabilities all mixed together.
Inflation theorised that the universe expanded so fast, faster than the speed of light in that early time, that these fluctuations created ripples in the fabric of space and time.
These fluctuations expanded and formed hills and valleys in the texture of the universe that allowed matter to clump into the matter we see today.
More precisely, inflation predicted that these ripples would leave a very specific signature of light polarisation on the CMB. Researchers led by John Kovac of Harvard University think they found that signature. We are now waiting for the upcoming observations by the European Space Agency's Planck Space Telescope, which is currently measuring the polarisation of the CMB and is expected to report its findings in October 2014.
This could more firmly establish inflation theory, and we will be able to look back beyond the 380,000-year horizon of the CMB, back to 10 to the minus 36 of a second after the Big Bang.
On that signal in the sky, we may be able to trace our origin.
We were once light.
Then we were ripples in temperature that became stars, galaxies, matter.
And life.